In this video, we're going to look at fixed size collections, otherwise known as arrays. Up to this point, when we've considered collections such as array list, hash map, hash set, we've identified the fact that they are flexible sized collections. In other words, they can store as many items as we wish to put inside them. We don't have to define in advance how big we want them to grow to. This is in contrast to arrays. So there are some problems where we know in advance exactly how many items of data we want to store. And these are the ideal situations for making use of an array rather than something like an array list or a linked list. Another difference between flexible size collections and array collections is that array collections can either store primitive type values without the need for auto boxing and unboxing, and they can also store object types as well. You might recall that when we were working on the tech support system, one of the tasks we wanted to perform was to split the user's input up into its individual words. And we looked at the API documentation for the string class and found the split method that performed exactly the task that we wanted. The only complication was that the return type of that method was something that we hadn't met before. And in fact, that return type was an array. In this case, the split method returns an array of string objects. So in this video, we're going to explore what exactly an array is, the special language syntax that Java uses to represent arrays, and how we can use them in applications where a fixed size data structure or fixed size collection is the most appropriate to use. The first thing that we'll notice about arrays is that they use a special syntax. It's the use of a pair of square brackets that tells us that we're dealing with an array rather than some other object type. So it's important to distinguish those square brackets from the angle brackets that we've typically seen with types like array list. Arrays are slightly unusual as an object type in that arrays have no methods. Instead, when we want to use a method to operate on an array, we're typically going to be calling a method that's defined in some other class. So we'll be passing an array object to a method of another class and asking that method to perform some operation on the array object. So for instance, in the java.util package, there is a class called arrays, and it contains a number of utility methods for things like sorting the contents of an array or filling an array with a particular value. And something to bear in mind is that the nature of those methods is that they will typically be static methods, methods that belong to the class and require no instance state in order to carry out their function. The scenario we're going to make use of in order to illustrate the way that arrays are used is what we've called the Weblog Analyzer project. So I want you to imagine that you've been asked by somebody that has a website to analyze their log files. In other words, when somebody accesses the website, a record is left of the visit that says things like what date, what time the visit occurred, what particular page they accessed, and so on. We're not going to write a full-blown weblog analyzer, but we're going to illustrate how we might perform one particular analysis on the data within the weblog. For instance, it would be quite common for the owner of the website to want to know things like which are the busiest days of the week, which are the peak periods of demand on the website, and so on. And if we're performing analysis on daily and hourly based data, then we have the distinct advantage that the number of hours in a day is fixed to 24. So if we're counting the number of accesses within an hour, for instance, then we know that we only need to record 24 separate values. So let's take a look at the project that acts as a form of weblog analyzer. Here we see a sample of the kind of data that our project is going to analyze. So we've stripped away everything such as which particular page was accessed, what the IP address was of the accessor of the page, and so on. and we've left behind simply the year, the month, the day of the month, the hour, and the minute at which the access was made. And our goal is going to be to record how many times in any particular hour an access is made to the website. So it's a very simple form of analysis, but it will nicely illustrate the fact that an array allows us to store 24 separate entries where we can accumulate for each hour of the day the number of times that web pages were accessed during that hour. So here's a version of the Weblog Analyzer project, and this version contains a visualization of the data analysis. So we want to analyze the hourly data that's in the weblog, and then we want to produce a visualization. We want to visualize the hour counts, and the idea is that each one of these bars represents the number of accesses for a particular hour within each of the days that the log covers. So this many accesses in the first hour of the day, this many accesses in the second hour of the day, and so on down. And there are some summary figures down here that says the total number of accesses was 3,749, and the maximum during any 1 hour was 237. So now we're going to look at the source code associated with how we would perform this kind of analysis using an array-based data structure. In order to do that, we're going to use a slightly simplified version of the project that doesn't have the GUI visualization. And we're going to focus on the log analyzer class. That's the one that's going to manage the data that we read from the log file. Here's the source code of the log analyzer class. And we immediately see in this definition of the variable hour counts that we're making use of the distinctive square bracket notation to indicate that the hour counts variable is going to be referring to an object of type array of int. So at some point we're going to be creating an integer array object, and hour counts is going to be used to refer to that array object. We naturally look to the constructor of the class to see the point at which this variable is initialized, and here we see that an integer array is being created. Again, the syntax is distinctive because we're dealing with an array data type. So notice, for instance, that there are no round parentheses in the construction of the integer array object. We would normally expect to see a pair of round parentheses used as part of the call of the constructor of a class. In the case of the creation of array object, we use the square bracket notation, and we write new int, and between the square brackets we say how many items we want this array to store. So this new object creation will result in an array of 24 locations, each of which can store a single integer value. So we've got two distinct elements of the use of an array here: the data type associated with the field and the creation of the object that field is going to refer to. And that's what we have here on the slide. So we further note that when we declare a variable that's going to refer to an array object, we don't at that point say how many elements the array is going to contain. That happens at the point that we create the array object. And we could visualize what that array object looks like as something like this. So it's an object to which the hour counts variable refers, and internally within that object we've got 24 separate locations. We access the individual locations by specifying the index of those locations. So just as we saw with the ArrayList class, the first item in the array is accessed with index 0, and the last is accessed with an index which is 1 less than the length of the array. So the index values for this array are 0 up to and including 23. So now that we've got an array object, how do we actually make use of it? How do we store items in it? And how do we access items once they're stored within it? To use an array, again, we use the square bracket notation. So in order to access an element of an array, we quote the variable that's referring to the array, we write an opening square bracket, and then we write an integer expression that selects the particular index within the array that we wish to access, either in order to read its value or to write its value. For instance, if we had a variable of type integer called hour, then we could use that variable as an index into the array in order to write a particular value at that index into the array. Let's look at how we use an array in practice within the source code of the project. We note that the project has several different classes within it, and so far we've only been looking at the log analyzer class. The log file reader class is responsible for reading the data from the input file and making it available to the log analyzer to use. So the log analyzer is going to interact with the log file reader, and it will repeatedly ask the log file reader to give it the next set of data so that it can be processed. So let's look at how that works in practice. Here's the analyze hourly data method. So the log file reader object actually operates quite like an iterator. We can ask the reader whether it's got any more data to provide to us, and as long as it's returning true from its hasNext method, then we know that we can go and ask the reader to give us the next set of data, which is encapsulated in a log entry object. So the log entry object stores the date and the time at which one particular access was made. We can then call an accessor method on that entry and find out which particular hour this entry refers to. And now that we've got that hour, we want to add 1 to the count of the number of accesses during that hour that are stored within the hour counts array. So we then use hour as our index into the array, and we want to add 1 to the count that's currently stored within that array. Now, we could in fact use the normal incrementation notation associated with integer variables, because the element at hour counts hour is a simple integer value. So we can say plus plus in order to increment the value that's stored at that location. So we're not incrementing the array, we're selecting one element within the array and incrementing its value. And this is a very common usage of the increment operator with an array. So to summarize what we've seen there, when we want to access an element of the array, we write the name of the variable storing a reference to the array or the name of the array, and then a pair of square brackets, and in the square brackets we write an arithmetic expression that's going to evaluate to a valid index within the array. And once we've done that, then we are referencing a particular integer location within the array, and we can do things like incrementing it, or we can test its value, for instance. So here are some of the standard ways in which we use arrays. We've got the hour counts declaration. For comparison, we've also got the declaration of a variable called names, which is going to be used to refer to an array of string objects. And it's important to bear in mind that in both cases, when we declare an array variable, or indeed any class variable, we don't actually have an array object at that point. There's a separate step required in order to create the object. So in the second example, there we've got creation of an array of 24 integers using the new syntax. But that syntax is slightly different from what we're used to seeing with the creation of objects like ticket machines and clock display objects and so on. So we're not calling a constructor of a class here. We're using a different syntax that is specific to the creation of array objects. And then when we want to use an element of the array, we write the square brackets after the name of the array, place an index inside those brackets, and then we can manipulate the associated element within the array in the normal way that we would any other kind of variable. There are a couple of other particular ways in which we can create array objects. So sometimes we know in advance what items of data we want to store inside an array. If that's the case when we're writing the source code, then we can in fact define the array variable, and then place within a pair of curly brackets the values that we want to be stored inside the array. Now, what's different about both of these examples here is that we are not actually specifying how big the array is going to be. The compiler simply counts the number of items there are between the curly brackets and creates an array exactly large enough to store exactly those values. Now, a point worth making is that if we create an array, its size is fixed throughout the life of that object. We can't ask the runtime system to extend an array or to shorten it in the way that we would typically do with something like an array list or a linked list. Now, if the array variable is to be initialized at the point that the variable is declared, then we can use the form shown in the upper part of the slide. But if at some later point within the life of that variable we want to assign a different array object to it, then the syntax is slightly different. Notice that in the first example we don't use the keyword new, whereas in the second example we do. We have to say new int, the pair of square brackets, and then that set of initial values is written between the curly brackets. So slightly different syntax used for the creation of an array object and initialization at the point of creation. You'll recall that with the array list type, whenever we want to find out how many items there are inside the array list, we call it size method. It's a different technique that we use for finding out the length of an array. So arrays have no methods. The way that we find out the length of the array is to directly access an instance variable that's part of the array object. So all arrays have an instance variable called length, and we can access that in order to find out how many items there are in the array. Now, of course, because arrays are fixed in size once created, we're not allowed to change the value of that length variable. So an attempt to assign to it would be errored by the compiler. In effect, it's a final variable whose value is set at the point that the array is created. I'm now going to introduce a new type of loop, and I'm introducing it at this point because this type of loop is often used very closely with arrays. We'll often see this type of loop used to iterate over a fixed size collection like an array, although it can actually be used much more widely than that. So the new type of loop is called a for loop. It's important to distinguish between the for loop that I'm introducing now and the for each loop that we've already seen. Here's what a for loop looks like in pseudocode form. At the top of the slide, we've got pseudocode for a for loop, and at the bottom there's pseudocode for the exact equivalent of a while loop. So the for loop has 3 elements in its header, and those 3 elements are separated by 2 semicolons. Inside the body of the loop after the header are the statements that we wish to be repeated. So they will be exactly like the kind of statements that we would use inside the body of a while loop or the body of a for each loop. The while loop equivalent shows us how we're to understand those 3 elements in the header are executed. So we can see that that first initialization step is only ever executed once, and it's executed before the loop's condition is evaluated for the first time. So that first element sets the loop up ready to be executed. We then test the condition. If the condition evaluates to true, then we don't actually go on to the post body action at that point. We immediately go into the body of the loop and execute the statements inside there for the first time. Once those statements have been executed, it's at that point that we then evaluate the post body action. And only after that's been evaluated do we then go back to the condition in order to evaluate it for the second time. And once again, if that condition evaluates to true, we'll repeat the process of executing the body of the loop and then the post body action and then evaluating the condition again. So what a for loop does is it makes explicit the fact that we often need some setup for an iteration, the initialization phase, And we often need an update step as part of the loop's iteration, which is ultimately going to lead to the condition becoming false. So we often place in the post-body action things like the incrementing of a counter that's gradually increasing until it causes the condition, comparing it against some maximum value, to yield a false value and the loop to finish. So let's look at a particular example. Suppose that we want to print out the count for every single hour that's stored inside the array. So we want to use a variable called hour to act as an index, and we want its initial value to be 0. We then want to continue the iteration as long as that hour variable is less than the length of the array. So as long as the hour variable is going to be a valid index into the array, we want to carry on executing the body of the loop. We go into the body of the loop, we print what that hour value is, we print a little bit of text, and then we use the hour variable to access the hour count at that particular hour within the array. Then we increment the hour variable so it moves on to 1. We then test the condition again to see whether that variable is still less than the length of the array. So we're guarding the array's accesses by checking to make sure the variable we're going to use as an index is within the valid bounds of the array. So hopefully you can see that for an array of length 24, the body of that loop will be executed 24 times. The value of the hour variable will start at 0, work its way up to 23. It will then be incremented to 24, and when that happens and the condition is evaluated, 24 will no longer be less than hour counts.length, and so the loop will finish at that point and execution will continue with whatever follows the for loop. So let's have a look at that within the source code of the Weblog Analyzer project. Here's exactly that method, showing you how the hour counts array will be iterated over using the loop variable. And we can illustrate how that works in practice by setting a breakpoint here and then calling the print hourly counts method. Here we are in the debugger. Here's the point we've reached within the source code. Stepping on, we can see that we've got an hour variable set to be 0. Here's our hour counts array, which we can visualize by bringing up an inspector. And we can see that each element of the array contains a distinctive value, the count for that hour over the course of the whole weblog. We step on, hour is certainly less than hour counts.length, so we enter the body of the loop, print out that count, hour is incremented to 1, we execute the condition again, hour goes up to 2, and so on. Repeatedly, hour is increased, all the time printing out the associated values until we reach the point of 24, and then the iteration finishes. And here's the resulting output. Because a for loop is closely associated with the idea of iteration over an array, it can also be used for iteration over other types of collection as well. And indeed, you sometimes see for loops being used with an iterator type. So here we want to iterate over the tracks collection of music tracks. So the initialization part of the for loop involves requesting an iterator object from the tracks collection. And then the loop condition is, as long as that iterator returns true from its hasNext method, we want to go inside the body of the loop, call the next method from the iterator to get the track, perform whatever task it is that we wish to perform, and then notice that in this case there's nothing else to be done. So we are able to leave the post body element as empty because the iterator is performing all of the management of working its way through the collection. We no longer have an integer index that we're using to call something like the get method of the array list. So what this example illustrates is that we can leave out some of the elements in the header of a for loop. In this case, we're leaving out the post-body execution element. We could also leave out the initialization element. For instance, if we'd already initialized a variable immediately before the loop was executed. So leaving out one or other of those two elements is quite common. We could in fact leave out the condition. That's more unusual, and the reason for that is it would lead to an infinite loop. If there's no condition in the header of the for loop, then that's interpreted to mean continue forever. In other words, the condition is always true. It's not uncommon to see for loops used other than with collections as well. So here's an example where we want to print out multiples of some number. We have a variable called num that we initialize to be 3, and as long as that variable's value is less than 40, we want to print the number out, and then in the post-body component we want to add 3 to the number. So we're printing out multiples of 3. It's an arbitrary example, but it illustrates that in that post-body part of the loop we can do many other things other than simply adding 1 to the value of a variable. It's just the component to be evaluated immediately after the body of the loop has been finished and before we re-evaluate the condition for the next time. So here's the while loop equivalent of what we're seeing there. So we've got initialization of an integer variable, we've got a loop condition as long as that variable's value is less than 3, we want to carry out the print, and then we want to increment the num variable by 3, come round and perform the test again. I mentioned earlier that we often use utility methods for operating on arrays, and there are several places where we can find array-based methods that we can make use of. So for instance, we might want to copy the contents of one array into another array. Well, the system class from the java.lang package has a method called arrayCopy, which takes two arrays as parameters and copies the contents of one array into another. I also mentioned that the arrays class in the java.util package has a number of useful methods. For instance, the ability to sort the contents of an array. We can perform what's called a binary search on a sorted array, a very efficient way of looking for a particular item within a sorted array, and another method such as fill. So it's worth taking a look at the java.util.arrays class to see exactly what sort of methods are available for operating on arrays. We might also want to take the contents of an array list and place them into an array. For instance, we might have started processing some data not knowing in advance how much data we were going to process, but then once we've established all the data in the array list, we would now prefer to operate on it in a fixed size data structure, and so we can ask an array list to return an array object that stores the same contents as the array list contains. So the array list class defines a method called toArray, which takes as a parameter the array to be filled with the contents of the array list. To finish this section, just got a few exercises that you might like to think about trying, just to see whether you've got the hang of the array syntax and the use of for loops with arrays. So suppose we have an array with some numbers in it. How would we write a for loop to iterate over that array and print out all of the numbers, one per line? Or suppose we wanted, in this case, to fill an array with a set of numbers, and the numbers to be stored in that array are part of what's called the Fibonacci sequence. So you can see in that sequence that each number is the sum of the previous two numbers. So the third number is 1 because that's the sum of 0 and 1. The fourth number is 2 because that's the sum of 1 and 1. The next number is 3 because that's the sum of 1 and 2, and so on. So could you write a for loop to create a Fibonacci array of some particular length of your choosing? As a review, arrays are appropriate where a fixed size collection is required. In other words, we know in advance how many data items we want to store, and we want to create an array of exactly that size and then fill it with those values. Arrays use a special syntax, so it's a little bit awkward to get used to using them to start off with, but you'll soon become familiar with the use of this square bracket notation in both the type definitions and in the creation of the array objects, and then in accessing elements within the array. We sometimes use for loops when we want to iterate over an array, where the for loop provides us with this natural structure where we define an index variable, we check the value of the index variable, and the post body part of the header then increments the variable to the next value as a standard way of iterating over the full array. We can also write for loops that are not necessarily used with collections, and it's not a necessity to always increment an index variable by 1.